In this video, you're going to be learning about some concepts and calculations in order to fill out the table you see below. Before we jump into the table, you definitely want to know that the atomic mass is equivalent to the sum of the protons plus the neutrons. And also, if you want the net charge of an atom, then that is going to be the difference between the protons and our negatively charged electrons. All right, in the top right over here, we have a little sample of oxygen of what it would look like on the periodic table. We have our atomic number right over here, which is going to be our most important number that we're going to grab for today. We have our element symbol of O, the element name oxygen, and the atomic weight. So the atomic weight of 15.999 is just the average of all the isotopes, but we won't really be using that atomic weight or mass in order to do anything we're doing today. Now, based on what we have in the first part of our table, we have carbon 13. Okay, so the notation for the element symbol is always the mass in the top left-hand corner, and then the atomic number on the bottom left-hand corner. So if I look up carbon, it's going to be 6. I can go ahead and fill that in. Now for the element name and mass, that is going to be called carbon 13. Now, the reason why you attach the mass with the element name is because the mass can vary based on the number of neutrons, which are different isotopes of the same atom. Now, this one says atom or ion, and for this one is just going to be an atom that actually should have been in the original problem. So this is just called an atom because it is neutral. Now, as for the protons, electrons, and neutrons, we have some things that we already know and then some things that we're going to have to calculate a little bit. So for protons, I know that they're always the same as my atomic number, which for carbon is always going to be 6. And then for the amount of electrons, if it is electrically neutral, then we know that the protons and electrons are going to be equal. And then as far as the neutrons go, because the neutrons are the sum of the protons, or excuse me, the difference of the atomic mass and the protons, we can take our mass minus the number of protons, which is 13 minus 6, and that would give us 7. All right, there we go. Our first one is complete. We have our carbon row all filled out. For the second one, we don't actually know the element, but we do have some different values that are going to help us out. The main one being 27 as our number of protons, which is always the atomic number. If we hunt down 27 on our periodic table, it's one of the transition metals towards the top, and that is cobalt. So cobalt, the symbol is CO. And cobalt, we already know that the atomic number or number of protons is 27. So I can put the 27 there, and then we know this is called cobalt. At this point, we don't have the mass yet. Now, we do know that the protons and electrons are not equal to each other, so we know for sure it's an ion. And it is a positively charged ion because there are more protons than there are electrons. So we would call that a cation. All right, now for the mass, we're going to take the protons plus the neutrons, which is 27 plus 30, and that is going to be 57. On the periodic table, the average mass reported is 58.63. Remember, that's kind of an average of all the isotopes. We don't really need that number, and we want a whole number for our mass anyways. So we know that this is called cobalt 57. And that's it. Oh, besides one more thing, we have the charge that we need to fill out. So if there isn't any charge put in the top right-hand corner, just like for carbon, then we can assume that it's neutral. If there is a charge, we have to report it on the top right-hand corner. So since we have 27 protons for this one, minus our 25 electrons, then our overall charge is 2. So we're going to call that a 2 plus charge. Okay, a lot of times people put plus 2. Either way, I think people are going to understand what you're putting down, but it's technically 2 plus. All right, let's get into our last row. We have zinc with a -3 charge, so we know there's an imbalance of the protons and electrons, and whatever the case is, we have 3 more electrons than protons to make that a -3 charge. Actually, that one's a 3 minus charge. So we'll call that 3 minus. All right, so for zinc, we can look that up on the periodic table. It's only a few down from cobalt, actually, and the atomic number is 30. So we can go ahead and fill in the name right there. And we also for sure know the number of protons, because the number of protons is the atomic number. And again, we already identified this is a 3 minus charge, so this one is definitely an ion, a negative ion, which is called an anion. All right. Also, before we said that there has to be 3 more electrons than protons to make it a -3 charge. So we know that our atomic number is 30, so this must be 33 to show that there's 3 more electrons than protons. Now, you have to be careful. You can't shrink the number of protons for zinc so that there's 3 more electrons, because the 30 protons is locked in for zinc. That's what makes it zinc. So you wouldn't lower the amount of protons. You would just add more electrons to have 3 more electrons than protons. All right, for our final part, we want to get our mass, which is the sum of our protons and neutrons. So 30 plus 36. So that is 66. So we have our 66 for our mass up here. And then we know this is called zinc 66. All right, so when filling out a chart like this, you definitely need to know a few concepts. Mathematically, it's all pretty easy. It's just some addition and subtraction. You just want to be aware of our 2 main formulas for the atomic mass, which is the sum of our protons and neutrons, and our net charge, which is the protons minus the electrons. And of course, you would want to know that the atomic number is the number of protons. It's going to help you hunt down your element. And when you're doing tables like this, you're not really going to be using this value right here. You're either going to be given the mass, or you would sum up your protons and neutrons. So I hope that was helpful to you. Thank you for watching and listening.